Yeah, peeps, Tersse, but no spot work, and this is, I hope, my final video in this series of fractal physics, fractal movies, fractal technology, fractals, As I started off with in the very beginning, I was talking about how I believe that fractal mathematics could be a boon to the physicists of the world. I mean, they are, after all, mathematicians, most of them, at the very start. I mean, you couldn't have any understanding of physics and the physical world without math. And I do believe that fractal math has been a very overlooked form of mathematics in the physics area of mathematics. I do believe that if you look at the universe, if you look out into the universe with a telescope, we do see spiral, galaxies. In a way, they are fractal-like, when you look at the Julia set especially. They are spirals, not so much the Mandelbrot set, although when you start to delve into the Mandelbrot set, you very shortly in certain areas find the Julia set recurring, and this is what I believe in nature. It is a recurring, repetitive thing. It's easier to produce something by repeating something you've done before than it is to make up a whole new thing to put on top of something you've already done, and I think this is something to do with the physical nature of the universe. We see this in the universe, in galaxies. There are many spiral galaxies. There are many galaxies which appear to perhaps maybe not have a spiral, but when you look at them deeper, they do have spiral bits to them. It's basically the angle of the view we see on them, which depends whether we see them as a spiral, top down, bottom up. But from the side, they are ovoid. And that's another kind of thing we see. We do rarely see completely spheroid galaxies, although there are a few. It could be there's something going on there that I don't have the ability to comprehend or explain here. Could be they just have a hugely more massive centre, black hole in the centre, or it could be that they have a much smaller, lighter black hole in the centre, which doesn't spin so fast and therefore allows it to look smoother and more circular, spheroid. I'm not going to go down all that pathway, but that's what I can say. But when we look at nature, it does repeat itself. You look at a leaf, you look at a tree, it's a repetitive sort of thing. You look at the vein structure of any living animal, it's fractal like. It branches from a thicker to thinner and thinner and thinner and thinner and thinner, and there's even a mathematical equation you can put to the size of the animal and the amount of branches it has in a certain distance, in order to supply the blood supply to all the cells it needs to supply blood to. There is a mathematical equation. It is math. Fractal structure is math, and it's a beautiful, simplistic sort of math, repetition. And what I find with mathematicians as well is that they are really into this. There is a repetitive form to mathematics called reiteration, and there is a lot of reiteration in a lot of other mathematical areas that don't involve fractal mathematics, but reiteration itself is a form of fractal mathematics. So where am I going with this? Well, where I started at the very start of this fractal group of videos. I do believe that physics needs to take another look at how fractal mathematics could give them another view on how they see the mathematical structure of the universe. This is really where I'm going with this. It's the end game of these videos that I've put up. I really do think physicists, mathematical physicists and theoretical physicists, because they work in images all at the time. Feynman, for instance, his great gift to mankind was the way that he pictured, you know, the Feynman, I can't remember what you call them now, but the Feynman pictures of, you know, the links between things, you know, and how he could look at it from not just a mathematical side, but from a pictorial, algebraic, I think, or whatever. I think it's algebraic. You know what I mean? But it's almost geometric as well, you know, and that's what fractals bring. The fractal math brings a geometric, you know, algebraic sort of look to you know, the universe. I think if we could at least get some physicists to try and incorporate some kind of fractal, you know, mathematical equations into their view of the paths of, you know, particles and, you know, neutrinos and stuff like that, you know, electrons around a you know, a central proton core. I think maybe that we might just get a different view on things, and perhaps there's a chance that we could see a little deeper into the mystery of what is the small, you know. Because, I mean, we look out into the universe and we see spiral galaxies, that's the large, and we look down into, you know, the smaller things, or even not so small things, but, you know, the way that, you know, rivers and streams and deltas form fractal-like, tree-like branching, structures. And then we look to trees and the branching of trees, and, you know, the Juliet kind of look to ferns, you know, the leaves of ferns are part of the Juliet set of mathematics. And then we look at the structure of the veins and arteries and, you know, capillaries in the human body or any other animal, you know what I mean? And that's, you know, fractal and Juliet as well, you know. And then we look down to even smaller things, you know what I mean? And there is a repetition. Rather than doing something new every step of the way, you just repeat the thing to a small degree and a small degree and a small degree. It's fractal-like, you know. The whole universe looks like a gigantic fractal pattern in some ways. Not in every manner of ways, but in some ways. But then we understand that when you go from the large, you know, from the gravitational, stability of a solar system, and then you go down to, you know, what holds together, you know, the atoms of your body, it doesn't seem to be the same thing. They're not all revolving around each other. That would be impossible. But within the localized area, there's a central core and things spinning around it. That's just, the atoms. And then we get down to the squiggles. But that doesn't make any sense. Why would you go from one thing which already works and works everywhere, and why would you go down to squiggles, to ones? Why wouldn't it be just a fractal pattern which is so complicated that unless you looked at it as a fractal pattern, then what you see is ones, because you're only seeing part of it. My imagination would take me to the point of, say for instance we could put a hadron collector, 100 million miles away from Earth, and then another hadron collector directly in its path, from the Earth to the first one, 80 million miles away, and then one 60 million miles away, and then one 40 million miles away, and then one 20 million miles away, and then one just outside the atmosphere of the Earth, and then link them all up with a gigantic computer the size of the moon, and calculate not only the path of a particle through those collectors, because obviously you're stopping some of the particles, but then you could make some sort of calculation of the particle that wasn't stopped, coming through the second collector, and then the particles that weren't stopped by that come through the third collector, the fourth collector, until you get to the Earth, you know. And you could probably make some calculation as to how those particles would have been affected by the attempt to observe them, and so how much energy was imparted on them to change the direction of the travel, but still have a calculation of their mass and their, you know, direction. And with a gigantic computer the size of the moon, you know, perhaps we would be able to you know, make some sort of calculation that would incorporate all the readings from all those collectors on all the particles that might be going through them, and eventually arrive at some, you know, more realistic idea of what a particle is and how it travels, what speed it travels at, and what effect it has on it by observing it, and have more information in order to make real calculations of not only where a particle is, but how fast it's travelling, and not just how fast it's travelling, but what direction it's travelling in, because we know that particles, although they might travel in, you know, straight lines, they're not all travelling in the same direction. I mean, light from one star, 1 billion light years to the west, is not travelling in the same direction as light from a star 1 billion, you know, 1 billion light years to the east. But somewhere those particles must be passing each other, and there must be some interaction between them which we just don't understand, because it's at such a small level of you know, interaction. We just don't have the technology at the moment to detect that, you know. But I do believe that through fractal mathematics we could probably find some way of at least estimating and at least guessing at the interaction of these particles and where they're coming from, and, you know, where they're going, and how it actually affects all the other particles in the universe that they pass, collide with, get near to, you know. I think fractal math, if incorporated into you know, real physics, real physical mathematics, real physics math, I think could open up a new window on the universe, a new understanding of particle physics. But that's just me. I'm just a crazy motherfucker with mind farts which probably just make people think, you're so fucking wrong, what the fuck are you talking about? But I look at it and I think, to me it's obvious that the world, the universe, and the tiny particles of, you know, this fluctuating reality that might be or might not be reality, but we just haven't been able to capture it. I think it's all the same thing. They're just repetitions and, you know, reiterations of what we see in a larger scale. We're just not seeing them like that. The problem that physics has at the moment is they are not looking at the small the same way that they see the large, because they've found all these anomalies which they can't account for. And I'm just thinking, maybe if we could bring some fractal math into it, maybe it would make more sense, because the fractal is the physical view, the pictorial view of roughness, not of the smooth, not of straight lines, not of curves. Gravity bends things, yeah, but does it bend it in a complete smooth curve? Does light travel in a straight line? I'm just thinking, if you looked at it from a fractal point of view, nothing is smooth, nothing travels straight, nothing. And if you looked at it from that point of view as a physicist, perhaps that will give you just the chink of light through, you know, the blacked out window that we seem to be looking at the universe through, you know. maybe just that chink of light to be able to make it a leap of intuition and devise some form of test that we could, develop to find out whether fractal math really has a place in physics. I believe that if we ever came to the realisation that fractal math does have a place in physics, and we did these tests, I think we would find out that it's true, and there is a way to determine that particles don't move in straight lines, and there's no such thing as a smooth curve. I really do believe that we would be able to come to that conclusion, and it would help us to understand the universe in a deeper meaning than the way that we look at now, with all these fine calculations where we need to have a perfect answer, or we just throw in, well, it's the unsure principle, or whatever it is. What is it? Shit. What's that? That principle you don't know what it is. I can't remember the name of it now. I'm a bit drunk. I've been drinking all day. Give me a break. I'm trying to expound fucking, deep physical fucking understandings of the universe here on very, very small things that I've never seen in my fucking life, apart from on TV. And they're just pictures, and what are pictures? The fractals. Haven't I proved that with the fractal movie thing, Didn't, Mandelbrot prove that way, what you see is only the smoothness of the rough underneath reality, and I think physicists need to understand this as well. Nothing moves in complete smooth curves, nothing moves in complete straight lines. It's all fractal. It's all rough and jagged and jumping back forward and up and down here and there and everywhere, That's the reality of life. It's the reality of our universe, I think. Physicists are just missing it because they love real answers, give or take, this or that, plus or minus. Well, maybe those pluses and minus aren't a plus or a minus. Maybe they're both a plus and minus because it's wobbling, it's jagged, it's jumping back and forward, it's not a smooth path, it's not a completely smooth curve. It's rough. Take an egg, for instance, a nice smooth egg, and then run your fingernail over it. There's no smoothness to it. It's as rough as a fucking old rock. It's a brick. Take smooth skin, for instance. There's no such thing as smooth skin. It's full of pits and holes where, the skin breathes through and exudes oil in order to, luxuriously, give your skin a lustre and shine and make it waterproof. You know what I mean? It's like, there's no such thing as smoothness in the universe. Everything is broken and jagged and rough, And the path of an electron is probably the fucking same. Physicists need to get wise to this shit, man, And then maybe we can make some real improvements on our view of this, tiny, minute, small of the universe that doesn't involve smooth, wiggly worms, It's why you fucking bad, motherfucker.